Okay, so good afternoon. I am Anto Budiarjo. Welcome to Monday Live. This is something that we do on Monday afternoons to figure out the future for smarter buildings. Our profiles are listed on mondaylive.org, just in case you're wondering who we are. And just as a reminder that views expressed here are personal, not of any company or organization. Just keep that in mind. And do please use the Zoom chat during this hour to have some interactivity with the panelists. We'd like to get a lot of interactivity as we can. And this slide deck is on mondaylive.org in case you're wondering about any of the links on it. So this is the fourth week of March when we've been talking about IoT, Internet of Things. So we're going to continue that for one last show today. And our agenda today, our normal news and trends sort of chit chat, and then talking about IoT. And really what we want to talk about is really sort of the future of IoT, the future of both OT and IoT in a world that is going to be dominated by AI, which is obviously what we're anticipating right now. So what is that going to look like? How is OT and IoT going to morph into an AI world? And this is part of our 3-month sort of series that we started in February talking about OT, then this month talking about IoT, and then we're going to morph into having conversations in April talking about AI. So it's all kind of part of this flow of conversations we're having. So looking forward to that today and April as well. But before we get into that, hand it over to Mr. Sinclair. What's going on, Ken?
Thanks, Anto. I like the progression we've got going here. AI is a tool, a medium, but without operating technology or IoT, it does nothing. So I think we need to keep focused on that we are an important piece of this puzzle. And so some of the stuff we're trying to sort out here is extremely important. Things like connection profiles, cloud native, and IBB. I plucked this off of Harvard, I believe it was, is AI won't replace humans, but humans with AI will. And the month of April is about discussing AI. And we've got a new contributing editor, and he's written an article, Embracing AI's Adaptability. And so he chats a little bit about that and how it's kind of going to reshape our personal lives. It's a seismic shift. There's a lot of skepticism, apprehension, and I think we all need to kind of get over that and get our heads around it. It is simply a tool or a medium. We've had some discussions about that. It's, in my mind, it's I think the easiest way to, in recent history, to think about it is what happened when Google search became such a powerful thing in our lives, and we tended to Google everything, and then we started taking pictures of things and having that into a Google search, and so we developed this new tool and this new power, and AI is just like that on steroids. So I think we have to get our mind around that. Another thing I think is from an article that was written before by Brian Collins. How should we dehumanize, sorry about that, AI? And I think we have to do it because every once in a while, somebody it's the people against AI, and that's certainly not the situation it is. It's a tool for people to learn how to use, and the people who learn how to use that tool are going to have superpowers, but it isn't the AI that has the superpowers, it's the people that know how to use AI. I think that's a good message. And then Keith made a LinkedIn post. Keith's one of our contributing editors. And, can a human fly an advanced tactical fighter without AI? And the answer is no. But the opposite is true as well, as the fighter can't fly without the pilot. So we need this relationship with AI. So that's a good read as well. So I'm pleased that I posted this few days before just to try and get a little spin on Monday Live, and we got good about probably 400 or 500 people looking at that. So that's there's some interest in what we're talking about. AI always draws interest, and looking forward to next month's sessions. Back to you, Anto.
Thank you. Thanks, Ken. Interesting flow of thoughts, as it were, as you said, leading up to April. So really great.
But I think the point is we need to add clarity to both OT and IoT relationship, because it is really the workhorse of what AI is going to do. AI can do some amazing thinking, some amazing analytics, but ultimately it has to turn the damper, start the fan, turn on the boiler, all those things. And the OT is the secret sauce to make all that happen. So I think we're in a very important place in life, and I think anybody that didn't know about our industry, which we all kind of said that we have a bit of an identity crisis, I think our identity crisis is about to solve itself as AI reaches out to us to do things.
Yeah, the NVIDIA CEO, Jensen Huang, I think that was his last name, made a comment last week. He was showing off some of their humanoid robots that they're working on. And his comment was that anything that moves in the future is going to need AI. And that's basically what you're saying, Ken. AI is a logical thing, and at some point it has to affect something. And when that affects something, that's really where things happen. And that's what he was talking about.
But our value is just in that statement, our value has just greatly increased because we're the people that move stuff, that we actually make things happen. We have the technologies in between, and you know, and not only do we have them that we can help them in the future, we can help them reach back into the past. And I think that's the exciting part, that because AI is going to be trawled over all of our existing buildings, and we're right in the middle of that. So I think a golden opportunity is about to fall on us again. What an industry.
Okay, so moving on, sort of related to that, this story on the left caught my eye over the weekend. This is a lady who's the CEO of or the executive director of CNCF, the Cloud Native Computing Foundation, basically saying what we were just basically saying, that cloud native and AI sort of go together hand in hand, right? And it obviously she doesn't go into the activity, the action side of things, which is our role, but the whole cloud native flow and the cloud native architecture and AI is really related to each other. And she's basically tapping into this. And I know, Rick, you've read this, and you want to chime in some on this?
Yeah, the timing is perfect. The timing's perfect in that, you know, I don't know, a year ago or so, we started orienting everything we were doing around the IBB and on, you know, whether it was 2525 around CNCF and all of the Linux Foundation work that had already been done. And with the thought that, as Ken has said, you know, we need to show the way for advanced technology to touch the stuff that, you know, our domain. We know how the levers work and how the 0 to 10s work and all the protocols work. But to see that the CNCF is, you know, absolutely embracing the path to AI is, again, just great timing. We're bringing our domain with using CNCF to AI, and it just couldn't be better timing.
And she was obviously also promoting the openness of all of this, which obviously lines up with pretty much everything that we've been talking about. So great stuff.
So, Anto, did you get the impression that the way she's thinking is that through the CNCF, they're going to establish some sort of a standard approach for representing and modeling data at that level in the architecture?
I don't know that that's what they're thinking about.
It
I
didn't,
don't know.
it's not the modeling of data. It's more the back end function, but I think, and she talks about it a little bit, the different domain expertise will come from the different domains. So the ontologies will come from, what makes sense for the different domains.
Yeah, it's very, very, very much in keeping with sort of the thinking that's going on in this group.
Okay, all right. Curious.
On the right, this is from Europe. Just some interesting data in terms of the environmental work being done on property. And in terms of the estimation, in terms of how much is going to be spent, but also sort of interestingly, the fact that green buildings, that's the term that they're using, is already in many areas more valuable than non-sustainable buildings. So there's just that kind of data and more money coming into the greening of buildings. So interesting trend, I thought. Again, the links to the summit was there here, just in case you want them. And we're still working on the RILCOM. We'll come back with that as soon as we know. And the link board is as normal. So, any other thoughts or any other news anybody wants to bring in? Hearing nothing, let's dive into Internet of Things. So really, it's kind of, this is the question, AI. So what is the role of OT and IoT in AI? And I didn't actually create any new slides or anything because I didn't really know how what specifically to lay out. But what I did was I just brought back the few slides that we've been using the last 2 or 3 weeks, and this is kind of the build up between this architecture, which is Tracy's EVO IoT system, and we sort of imposed how superimposed how IBB architecture would look in that application, in that use case, and then started to think about how connections can go across all of these systems. So the reason I just brought this up now is, this is kind of a mix of OT and IoT. This is why we've been talking about it the last couple of weeks. But the question that I have is that, where's AI in this? How is AI going to be represented in a diagram such as this? And, so that's kind of one way of thinking about it. The other way is that, again, we were looking at this diagram last week, is the silos. So where's the AI here? And the AI is within the silos, or are they somehow helping the blue lines over the silos? In other words, are they outside of the silos, or are they sort of a layer above, or is it everything? And another sort of pictorial way of drawing it, this is kind of a system of systems things. And so again, where's the AI? And another way of depicting that we've been using a while, obviously, the smarter stack. So again, the question is, where's the AI? I'm not sure there's a specific answer or right or wrong answer, but I just thought I'd bring that up as a way to start this conversation off, and hand it over to the panel. Any thoughts, anyone? I'm going to stop this share.
Go back to your stack, actually, Enzo.
Okay, can do that.
I think one of the first things to recognize is AI can play a role in virtually any layer here along this stack, right? So we all tend to use AI as a general term to describe everything. It's kind of like saying software, right? Where does software play a role in this stack? Because remember, that's really what AI is just software. So, you know, I think one of the things that we need to be careful to do here as we're talking through this is, and we ask general questions like, what's the role of AI? We need to recognize that actually there's a role for AI throughout this entire stack.
Yeah,
I don't
for
have
sure.
brilliant conclusions about that, by the way. Just
Yeah,
because when I think about it, when you think about this whole stack and you start down at the physical layer in the different devices, the AI can literally be driven down little snippets down to individual sensors that are pre-processing data, doing things, learning, recalibrating themselves, doing fault recovery kinds of things. And then of course, up at the top side of this, we all recognize large language models and what they can do from a user perspective. So it really can go all over. And when we're still kind of in IoT month, when you talk about IoT tying into this, I think the role of IoT in this big picture, more than anything, is all of these connections to different points of data, different systems, different devices that we never had access to before. If you even go back 5 years ago, you don't see the number of what we kind of historically here have called IoT systems that are these smart applications, smart bathrooms, smart toilets, smart faucets, smart urinals, whatever it might be, let alone some of the core kind of building stuff. So IoT is really expanding the availability of data in a building in terms of really modeling and creating kind of that digital twin that we've talked about.
I think that's a great opening, Tracy, and yes, AI is part of everything. I think one thing I believe AI can do for us is it can help us keep current with the dynamicness of this, because the AI is ever evolving. And you kind of look at this smarter stack and it was like a static snapshot in time. Basically, I sort of see it as AI building the smarter stack in dynamic time. And so when a new mobile personal app does something, adds health to its abilities, the next time you generate the stack, it is a lot smarter than it was the last time. So I think we have to kind of change our thinking to, I see one of the big advantages of this tool is its dynamicness, the fact that it can, we all have in our little minds a picture, and the problem with that is as we keep busy doing something else, we come back to the same picture. But by the time we get back to the picture, everything's changed. So I think AI is going to help us in that area.
Keep track of everything that's changing.
Correct.
Is
I think,
one of
I think
one of-
AI is
one of-
excellent at doing that.
Yeah.
Every time I do an AI reach or grab or search or what you want to call it, I don't even know what you call them. I'm amazed at there's always a piece of it that amazes me that I didn't know before I did it. And that's so then I say, wow, this is really a useful tool, medium.
And the other thing interesting about Tracy's comment that AI is pretty much in all of these boxes, and I think we all kind of instinctively sort of agree with that, is that AI is going to be, these boxes are different boxes. They do different things. So in a way, I mean, it's another kind of, but we're thinking of AI of having the ability to do lots of different things, which is again kind of obvious, blindingly obvious, but in a way we've never had anything like that before. I guess that's what I was trying to say.
I think we also have to be ready that AI will probably create some new boxes. It might even warp the stack.
So let me ask, we've been discussing about what is AI, and Tracy just a few minutes ago argued that AI is just software at the end of the day, right? But what distinguishes it from and commercially we're hearing AI segmented into things like generative AI as an example, and then machine learning, as we've said, that in our minds that's an example of AI, and yet the fact is our industry's been applying machine learning for some time. So I want to raise that now as a point to see if we're already part of the way there. So if you take analytics packages, Jim's not on the call today, I don't think.
Yes, he is. He is.
He is? Okay. So Jim, all the rules scripts that I'm assuming you run in your software for analytics to look for conditions that crop up, and then you warn on that. Do you consider that AI?
I struggle with the definition of AI, Steve, as I've mentioned before.
Yeah.
We call it rules-based analysis, and
Mhm.
in the broader world of AI, I would consider it AI. It is certainly not large language models,
Right.
but it is the beauty of a rules-based technique is that you can actually do root cause failure rather than probabilistic techniques.
Exactly.
So
exactly.
If John Petsy were on the call, he would basically say that there are different tools for different jobs, and for traditional FDD in HVAC or building automation, rules-based is probably a better way to go. That's not to say there aren't a number of great applications for AI in that picture, in terms of setting up and configuring and improving the models that the rules function on.
Yeah, so you could actually optimize the model. You could actually optimize the rules themselves through continuous learning.
In fact, that has been part of our process for many years, and I think most people in the industry do that, whether there's a human in the loop or it's just pure machine learning. If you want to consider that AI, every time a rule evaluates a problem, we're taking data on how good a job it did in doing so, right?
Yeah.
And making course corrections as we go.
Yeah, I guess my reason for bringing all this up is I don't want to fail to take credit, if you will, as an industry for what we've already accomplished with these rules engines from an analytics standpoint. We may not have the adoption in the marketplace that we wish we had. Obviously, we've talked about that many times. But what they actually accomplish when we get the opportunity to apply them is quite impressive.
I would agree with that, Steve, and a lot of people would like to say that we're late into the game on a lot of things.
Yeah.
I completely disagree. I think we're ahead of the curve, especially a lot of manufacturing sectors. And there's a reason that's true. A lot of manufacturing processes are actually simpler than the kinds of work we do. The other thing is that there's more building automation than any of these other fields. We've talked about this before. How many paper mills are there in the United States? How many auto assembly plants? The numbers are tens, 50s, or hundreds, where the numbers of buildings are in the millions, right? And even in large buildings, they're in hundreds of thousands. So you've got more orders of magnitude of place where you can apply this technology. And that's one of the reasons that our industry is ahead, not behind in a lot of these areas.
Yeah, so part of my argument, Otto, and the rest of the guys, is that analytics, which is largely being done in a dedicated application, whether it's premise-based or cloud-based, I do think due to the way computing is evolving, we'll increasingly be able to do analytics down to the edge, down to the individual devices. But it's not necessarily going to change exactly what we're doing. In other words, I still see it as largely rules-based logic that will be added to conventional control algorithms to optimize all the way down to the edge. But the point is that analytics at the edge is an expansion of what we're already doing. It's not a reinvention or a complete new thing. It's just the fact that the horsepower of these microcontrollers is such that, and the amount of and the availability of very inexpensive memory allows us to put this kind of capability into very small devices. That's my argument.
I'd like to make another analogy on that, Steve. If you look at large language models as a system that has gone through all this data and is, probabilistically guessing the next word, right? Mm-hmm. I mean, if you took the rules of grammar for the English language and checked what it came up with, you're going to be a lot further ahead. And in fact, that is an imposition of a rules-based system on top of one of these other systems. So, we're already, in a way, doing that in our sphere.
Right.
I think there's an opportunity. I think there's an opportunity to what we need to do is start moving our industry into these. I'm not sure if I've got the term exactly right, the large language models, but what we need to do is to have this dynamic look from AI's point of view of what is going on, because just that simple analogy that we're moving analytics from the middle to the edge, or from the top to the edge, whatever what we're doing, and the degrees of that will be varying on all particular pieces of data, and just the mindset of trying to sort some of that stuff out. I think AI could help us. So I'm thinking that somehow if we could build a bit of a fence around some of our thinking for a particular building, and then have it, I guess it's maybe on the edge of digital twin, I'm not sure, but that might be an interesting discussion, what AI might mean to digital twin.
That indeed is an interesting intersection. I'm sure a lot of people have been thinking about it, but not quite sure how we could dig into that.
The relationship between digital twin and
AI,
and the learning of AI. I think it would basically could learn the digital twin rather than just letting it go out into the world. But it could go out into the world and find new technologies to bring back to the twin.
Great example of AI being used at different parts of a stack. I wanted to go back and reiterate a couple of things that were said. I mean, at the risk of being obvious, Tracy said, AI is just software. And, honestly, we really haven't in our industry. We've been using software, to all your all's credit. We've been using software, but it's been in silos, or it's been in PLC, programmable logic circuits, PLCs, or it's been in isolated devices. And to the point that Steve made, the price of chips and the price of communication, the price of RAM has come down so far. And the new software architectures now allow software to be run in more places. It's, again, super, super obvious. So the software that's been used in the expensive places, and you all know me, I like to say the Internet of expensive things. The same software is now going to be able to be run in a lot more places because of the price of the chips and the access of communications. What'll be interesting, though, is that when all these different chips become aware of each other, because they are smart, And the old architectures of thinking about Internet of Things where the sensor had to go all the way to the cloud because that's the only place where the software was.
Right.
That architecture of the past, well, there was only one place, quite often, there was only one place where the software actually existed. The new architecture that we're talking about, going back to the CNCF mention at the beginning of the show, Cloud Native Computing Foundation is an architecture that says the software can now be run anywhere. So you put the price of the chips and the ability to do the processing and the communication with a new software architecture pioneered by CNCF that says I can now run software anywhere. Then you throw AI into it. It's a whole new world. So all of the stuff that we've done, the brilliant work that you all have done, can now be unlocked, unleashed, and be you can sell it more often to more places.
So from perspective of IoT, is it safe to assume that IoT is destined to just bring in an increasing amount of AI into their devices and their cloud services?
And
they're gonna do that.
non-cloud services. That's the point I'm trying to make, is IoT inventors are right now using new architectures that are not dependent on just the internet.
Right, so it is similar to what we're talking about, the cloud native, yes. And implementing AI in those IoT systems.
Making IoT artificially smart is the business of the day. And the closer you can do that in a device, then it's easier to make it understood as a product and something you can sell. So I think IoT will make everything grow in our business. It'll make IoT grow, it'll make OT grow. Everything we do is going to be accelerated because of AI.
I guess I wonder if the notion of AI going to the edge, I think it's inevitable just from Moore's law's perspective. But if AI is going to end up in a temperature sensor, for example, right? Is that temperature sensor going to be able to do anything more than sense temperature and tell everybody what the temperature is? And what is the purpose of AI in that? To predict?
Sorry,
Tracy?
I was muted. Yeah. There's a couple things in that when I was thinking about that sensor example. So again, nothing that's extremely new. I can't remember if it was somebody at NIST or PNLL that was working on a project for sensors that are kind of self-calibrating and fault recovery sort of a thing. It was a while ago. I want it was pre-pandemic for sure. But if you kind of break down AI and look at it from kind of its what's foundational, right? It's a lot of it is about mathematics, and AI uses 5 or 6 different areas or fields of mathematics combined to provide more accurate predictions and information, and hence the learning quality, right? So on a sensor level, if a sensor has the smarts to, perform some basic linear algebra, for instance, and transform matrix faster or locally, filling gaps of missing data, again, allow it to self-calibrate. At the end of the day, you still get a temperature out of it, but
Right, and nothing else.
yeah, one of the things that we've complained about with AI is garbage in, garbage out. Well, this is how AI, helps solve that problem, right? If you can get more accurate data coming out of all your devices, all the way through the stack, whether it's a single temperature point or it's something, a little bit more involved up the control stack a little bit, then everything overall is going to improve. AI is going to, the higher level generative type AI applications are going to improve. So remember that not AI has to solve a complete complex problem. Sometimes it solves a really small problem really fast and at great frequency. So.
Okay, a couple of observations I'd like to make is the AI, edge AI, in my mind, should have the ability to reach out to cloud AI anytime it wishes. So I think if we, way back when Toby Considine wrote an article on automated buildings about stuff on the ground, and we had to have, it had to be wired back in those days. I believe where we're heading is that IoT with the sensors and analytics on the edge and that whole, it's an actual thermostat that has a chip in it, and it has all those relationships. That is the new ground, that device. And if that device loses communications, it still has to control the temperature in the room. So that's job number one. But I see no reason that it cannot reach out to higher AI to look for the room count, the amount of people in the room, whether it's day or night, whether the lights are on, and those kinds of things. So I see, I see the edge, but AI will be able to help that sensor be a better sensor, but should it not be able to get that help because the communication has been severed, it should still be able to do its job. So our definition of what is on the ground and not in the cloud, I think, is changing a bit.
So you're sort of implying that the reason why that sensor became a better sensor was its ability to communicate with other entities that are likely to be AI.
That's one thing.
Does that
Yeah,
resonate with
this-
people? Does that make sense?
I would say this is like anything else that we've talked about where, there's a whole school of thought that says, look, let's just assume everything is connected or everything's going to be connected, and then talk about a world where everything is connected. And that's very IoT thinking and centric, right? I am connected.
Right.
But realistically, there are standalone systems or standalone devices for various reasons, or when devices become or systems become disconnected unintentionally. There's still intelligence built into that can cause all of that to operate more efficiently and better and more standalone, I think. So we have to be careful. When I look at this, I don't think of it as one or the other. I think IoT is a kind of a waypoint along the way to our final destination of whatever that full stack of intelligent controls looks like 10 years down the road, let's say. IoT plays a role of expansion and really getting more out there and building more intelligence into IoT, I think is, an obvious and necessary byproduct of everything that's going on.
But one thing is, like our phones, if we are not connected to cell or we're not connected to Wi-Fi, the phone still has some function. It can
Right.
still get us a phone number, it can still maybe find a picture. And I think that's the new definition of sort of ground IoT device is a dead cell phone isn't on a cellular network, and actually it still does something. And that's the definition of our controllers. They have to have that level of understanding. As soon as the cell network returns or the Wi-Fi returns, it becomes infinitely smarter, and it becomes an amazing device. And I think that's the way the new AI devices will evolve.
Well, this comes back to something that Rick has harped on a few times, which is Moore's law, right? I had a really interesting happy hour conversation long time ago with a couple of the guys who, quote unquote, invented LawnWorks, right? This all started back at Apple. I don't know if everyone knows that, but one of the things they used to do at lunch is stand around a whiteboard and ask really interesting, hard questions. And one day the question came up, what would the world look like if a computer cost $1 and it was the size of a little microchip that could go into a light switch or on a light bulb? And then it just evolved from that, right? So if you kind of extend that thinking and say, what would the world look like if you had enough resources, memory and computing power, small enough, cheap enough to go into light bulbs and temp sensors and so forth? What could we do with that? What would we do with a 3-cent supercomputer that could fit on the tip of a temperature sensor probe? Because that's Moore's law in action, and that's what this is all about. If you can run more mathematics and more algorithms, more raw code locally, then people will eventually find a way to apply that, undoubtedly. And that's, I think this whole thing is a bit of an evolution through IoT, AI. It all starts to blur in my mind.
So there's sort of an implication here that sensor that I mentioned earlier could be communicating all the time with the cloud and with a whole bunch of other things, right? So in other words, layers don't matter anymore. The stack doesn't matter anymore because a system that's at the lower level can communicate directly with something above. Okay, that's great. So I guess what it's sort of leading me to think is stacks. I mean, we have the smarter stack, and there's a ISO 7 model stack, and there's a whole bunch of different stacks, right? Stacks were not created just to delineate technology differences. Stacks are also created to help us organize the world. Right? So I'm wondering if everything's connected to everything, then don't we still need a way of us human beings and AI ultimately to organize things, because it's not just one big chaotic jumble.
I would say right off the bat, think of the smarter stack as a 3D model instead of a 2D model, right? So where layers are communicating within them, other, the same level layers, or maybe up one layer and down another. We really need to start thinking about this a little bit more Matrix-like 3D. And I don't mean Matrix the movie, I mean Matrix like the mathematical model. So just with that, even if I know this sounds really oversimplified, and I don't mean to be the Captain Obvious here, but think about humans and how we communicate and how we learn and how we get smarter. We don't communicate up and then back down. There's no hierarchy there. It's very organic, peer-to-peer. Sometimes you communicate with people who are really a lot smarter and you learn a lot, and other times maybe not so much, So when this all evolves and opens up and you have that level of open communication and ability to cross communicate, that changes how our current hierarchy of systems are and becomes much more organic. And that's a different model altogether than what we're used to.
And the bottom line, the objective of all of this is to get as much data as possible to wherever or whoever can actually use it. Doesn't matter where.
The right amount of data.
That is one objective. But I mean, to get back to Mark Peacock's philosophy of what are the outcomes here, I think that the silicon is free theory that Rick has been espousing, everything you guys said is true. Unfortunately, it doesn't represent the whole picture when it comes to value. Where those sensors are and what they're doing has a lot to do with other people's systems that they go on top of. for instance, the mechanical systems that are underlying them. So it's really the outcomes and the value proposition of the IoT is not just about organizing the IoT. It's about organizing the entire ecosystem to come out with a better outcome. One of the problems is that we don't necessarily even have influence or control over the mechanical systems. And just a point in question would be, if you had brilliant sensors and actuators and automation on every VAV box, how do we know they're going to put enough VAV boxes in, right? I mean, suddenly we don't have room control if we don't have enough VAV boxes, so we can't affect the outcome, right? So my point is that we don't just have to optimize everything from an IoT or communication standpoint. We have to take into account optimizing the systems we're running with. And that might even go down to challenging the fundamentals. For instance, is VAV the best way to do air conditioning in a building?
Right.
So many things are done because they had to be done, not because of, gosh, what could we do if, to Tracy's point of, standing around, and it didn't make too much sense to spend too much time at lunch talking about that because it didn't matter. You couldn't do it yet. The price of the chips were what they were. So engineers have always been brilliant about being able to do things in where there's a scarcity of resources, and imagining what could be done if there was an abundance of resources, whether it's processing or whatever. But that's one of the things that is going to happen, is that, as Jim's point about, is VAV the right way to do heating and cooling? Have we been doing things the right way, or have we been doing things based on what we could do, the physical limitations and the scarcity of resources? We've done fabulous based on that, but now there's going to be some resources that are less scarce. And so now we can do software different. We can do data different. We still got to do BTUs the same damn way we've done BTUs for a long time. But there are things that are freeing up.
Yeah, scarcity thinking, I think, drives a lot of this. And so I brought this up a while ago, but you were at presentation that Vint Cerf did at GWAC a while ago, who got up and challenged the whole idea of energy management. Why? That's a dying thing. We don't need it. What we need to be focusing on is abundance thinking, that energy is free and abundant and plentiful. And why do we need to worry about conserving energy anyway? Right. So it's just flipping how you're thinking. And I think Jim's right there. That, we don't know what we don't know when it comes to how do we cool buildings, right? There could be a whole other way to provide, comfortable environments. I'll just say it that way.
Yep.
Not air conditioning, just comfortable environments. So.
And with all of this, we also still have to bear in mind that all the different trades and all the different things that need to happen by humans, installation and commissioning and everything else, right? That probably a lot of that won't go to AI immediately, or the processes and the business models and everything else doesn't go away. Probably will need to change or adapt. Okay, so where does this take us? Well, what does it look for OT and IoT and AI? Well, let's just look at OT and IoT. Are both of those well positioned to adopt AI? Maybe that's an interesting question.
I as we've been going through all this, I can't stop myself from thinking that this is OT and IT are going to be benefactors in the sense of a PID loop as AI gets kicked into this whole thing, right? This is going to be this continuous cycle of innovation and improvement that improves the next step along the process. So I think that this general, we're thinking a little linear here, but it's maybe not quite as linear as, when you lay it out on a slide, OT, then IoT, then AI, that's,
Right.
I don't think it's quite that simple. I think there's a lot of feedback loops here, and things improve over time. And as IoT gets more invasive and spread, OT gets better. And as OT, understands that they have more information and things to do, they'll ask for more out of the systems, and so on and so forth, right?
I think the other thing too is AI is a brand new tool. None of us know how to use it well. And as we use it, it'll become obvious. It will teach us how to use it better. And so I think that'll be an evolution that'll change. This discussion a year from now will be much different, and 2 years from then, even more.
Yeah, because we'll start to see, I mean, it's almost like we're building a lot of this conversation around our experiences with ChatGPT and things of that nature, right? And as we progress with AI being implemented in these up and down the stack, we're going to start to see what that actually looks like, and that will shape our thinking about what actually should happen, what could happen. That'll be really interesting.
I'm still thinking on that. I know, and I want to ask this question back to you, Anto, is I know you're involved with the digital twin groups. What has this topic come up in their camp? Because it's an interesting thing. We created the digital twin to basically simulate a dynamic simulation of the building, and my roots are in computer simulation. So it's interesting that could be a learned model with a fence around it, and AI might be able to add great value to that. Is there any discussion on that, or it's just a thought in my head?
I think that is the model that a lot of people are thinking about digital twin and AI. Once you have a digital twin, if you have a proper digital twin that is actually a twin of the whole system, of the whole physical system, here we're talking about buildings, and of course you can apply AI to that digital twin to see what's going to happen to the building, to predict, to simulate, to all sorts of things. I think that's a huge sort of benefit of a digital twin. I think the problem is that both digital twin and AI are terms that are a little bit confusing, right? So people are still thinking of digital twin as the visualization and the simulation, and that is almost what AI is. So, the differentiation between the two, I don't think is as clear, because the terms are not that clear, because we've sort of made it convoluted ourselves.
To me, the big difference is borders. A digital twin has a border around it. AI is kind of the world is the border.
Okay. Yeah, a digital twin is a digital twin of something. That's what you're saying, and therefore that is a boundary.
And a model I can learn as AI.
Right.
Well, I can
And
deploy or employ computer simulation and AI, right?
Exactly. You can deploy AI to that model, to that set of data, to that digital twin.
Back in the early days of computer simulation, I mean, that was the first task was to basically define where's the envelope of this building. And I suspect in digital twins, it's a bit the same. So yeah, so it's just basically a controlled environment that we can really release the power of AI inside. Anyway, interesting thoughts.
Yeah, no, I agree. It's an interesting intersection. It's just very difficult when these terms are still fluid in their own rights.
Hmm.
Cool. So any other sort of perspective on IoT and AI before we wrap up?
Well, I guess, Mark was making the point that analytics at the edge already exists, and I think that's true for IoT, IP-based devices. It isn't necessarily true in the case of IoT for raw sensors. Okay. Because they're basically taking their value and reporting it up perhaps through a gateway to the cloud, and then anything relative to what you want to do with that data is done through an application at the cloud. So with the question I have is, are we going to, because of the cost of everything coming down, are these raw sensors going to become, if you will, more self-describing by putting intelligence in them, and communications, and behave more like an instrument instead of a raw sensor, and such that you can mount it, you could optionally power it off a cable from your laptop, and you can immediately see what it's doing, what it's reading, the kind of device it is. If it's battery powered, you could absolutely get all kinds of information from it in terms of what it's seen historically. You could put in alarm thresholds right in the sensor itself. So if it was Bluetooth enabled, you could communicate to your phone directly. So the question, so whether you call it analytics or you call it smart sensors, I'm just arguing that from the IoT perspective, I think that the future will see more and more of these sensors becoming far more capable than just a dumb sensing element in a package. Is the argument I'm making here, which will lend itself to a much more capable local IoT solution than one that's dependent on the cloud for whatever it's doing.
Another thought on that is maybe AI will interrogate these sensors and basically pull out all of their capabilities and information. And the dream for me would be that AI will create the connection profile and hand it back to me, and I don't even have to think about it.
Well, the concept of self-describing, self-reporting devices is not foreign by any means, right?
Mm-hmm.
So,
and it's something that's very core to what we're trying to do here, is to make data discoverable. But I think it's a sort of a closing comment maybe on what you said, Steve. So what you're sort of saying is that a sensor could have AI and slowly become much more than a sensor. And
Right.
when does a sensor stop being a sensor? It becomes a
That's right.
controller. It's no longer a sensor when it has all of this stuff in
it
it.
performs a function. It performs a key function, which is translating some physical measurement into a digital value, right? It does do a measurement that a quote unquote computer does not without a sensor of some kind, right?
So do you still buy a sensor? The line item, does it say sensor or does it say compute? Or does it?
That's going to be interesting. I mean, going back to, Jim, I love that term, free silicon. If it was free, every sensor could talk any protocol, any language, and have unlimited computing power and memory, what would it look like?
Yeah, right. Yeah, so for example, I'd like to have the sensor tell me whether it's defective.
Yeah.
Right? Something very basic, right? So if the temperature sensor is no longer measuring temperature accurately, let me know that.
Yeah,
so
and that's already in process, like I was saying before. There are people looking at that already.
Right.
Going back to another thing that Jim said, do we have enough VAVs? Well, in that kind of a world, you throw more of these sensors out around the building and help model it and figure it out, right?
Yeah.
So that's the IoT part of it, connection, right?
Right.
All right. I think we need to wrap. Past 4 o'clock on the East Coast here. So thank you very much. This has been a good, spirited conversation. And so this wraps up IoT month. And next week, we're going to start talking about AI.
April Fools.
Really looking forward to that. Okay. Leave it there. We'll get the video
All right.
out. Bye-bye.
Bye,
Thanks,
everybody.
everyone.
Thanks.
Bye.
Bye.